So in 7.2, we are still dealing with exponential functions. So we're still dealing with functions that were of the form y equals a times b to the x power. But what we're doing today, just like we did with other functions in the past in this class, is that we are now going to talk about more detailed graphing of these. Okay, and basically what I mean by that, I mean shift. All right, we've done that with every single other function we have graphed in this class. We've graphed lines, and then we've shifted lines. We've graphed parabolas, and then we shifted parabolas. We've done that with absolute values. We did that with square roots. We did that with circles. Okay, every graph we have done in this class, we have then also shifted them. And they have shifted the same way. It's always that h and k, right? X is hexed, y is y's. Same thing goes for exponential functions. This is the equation that you need to know. This is our general form for exponential functions. Okay? The a value is going to tell us whether or not it opens up or down. Oops. And we saw one example of this in our homework from last week. That was that one last problem on that worksheet where it had the negative out in front, and I told you guys, oops, that was my mistake. I didn't mean to put it in there. Right? Remember that? No? Yes? Okay. So that problem, if you had worked that problem, you saw that problem actually opened down when you graphed that. Okay? So same thing here. If a is negative, our graph, rather than opening up and looking like this as an exponential growth problem, it would open down looking like that. Okay? That's what a does for us. Okay? That's what a does for us. Now, x is our, for x-axis, that's our horizontal movement. And so anything that's attached to the x moves us horizontally. So the h, just like it always has, moves us horizontally. So the h shifts us right and left. K, just like it's always done, shifts us up and down. Okay? So these values, these variables, a, h, and k, are going to do the exact same thing they have done for every other function we have dealt with in this class. Every single function, if the a value was, like for a parabola, if the a value was negative, the parabola opened down. Okay, absolute value, if the a value was negative, the v opened down. Same thing now. And same with h and k. Remember our phrase for h and k, for shift? Anybody? X is hexed. Y is wise. Because that says whatever is in here with the x, we do opposite what it says. If it says x minus 4, we actually move to the right 4. If it says x plus 2, we actually move to the left 2. X is hexed. We do opposite what it says. Y is wise. The y is the k value. Whatever it says, that's what we do. It says plus 2, we go up 2. It says minus 4, we go down 4. Just like we've always done. Any questions? So let's look at an example of this. If we look at our problems, let's just take a look right here. Okay? So we're just graphing y equals a times b to the x. This is actually no different than the graphing we have done for the last week. Exponential functions. The only difference now is that our a value happens to be negative. Okay, so since our a value is negative, I know that this graph is going to open down. Okay, but there's no shift involved. It's just going to open down. So let's go ahead and start our t-chart. Remember, I like to plug in -2, -1, 0, 1, and 2. We, by all means, can plug in more points than that, and we very well might. Okay, so plugging into here, remember we have y equals -1/3 times 3 to the -2 power. You always have to evaluate the exponents first. You have to do this part first. So what is 3 to the -2 power? 1/9. Very good. So now we have -1/3 times 1/9. And what is -1/3 times 1/9? -1/27. Okay, so next we have -1 for x. So y equals -1/3 times 3 to the -1st power. Again, evaluate the exponent first. So what is 3 to the -1st power? 1/3. So we have -1/3 times 1/3. -1/9. Okay, so next up we have y equals -1/3 times 3 to the 0 power. Again, evaluate the exponent first. What's 3 to the 0? 3 to the 0 power is 1. Anything to the 0 power is always 1. So we have -1/3 times 1, which is -1/3. All right, we can probably speed this up a little bit. If we're plugging in 1 for x, what's 3 to the 1st power? 3. What is -1/3 times 3? -1. What's 3 squared? 9. 3 squared is 9. What is -1/3 times 9? -3. Let's go one more step here. Let's say if x is 3. So 3 to the 3rd power? 27. What is -1/3 times 27? -9. Very good. So now we can go ahead and graph these points. There's no shift here, so therefore we're graphing them right in their proper place. So at -2, we're at -1/27. I can't graph -1/27. That is so close to the x-axis, I'm not going to be able to graph it. -1, -1/9. That one is also extremely close, but I'm going to make an attempt here. So the attempt is going to look pretty much like it's on the x-axis. Okay, because -1/9 is so close to the x-axis, really I probably shouldn't try to graph it. Okay? 0, -1/3. I can graph that one fairly well. There's approximately -1/3 of the way down. Then we're at 1, -1. Okay, 2, -3. And then 3, -9. Now here's something, before I plot that last point, I want to show you guys a few things. So when you're graphing these on your quizzes, homework quizzes, and I haven't graded your big quiz from yesterday yet, but it's probably going to see the same thing. I'm seeing people do things like only connecting the dots and calling that your graph. You have not graphed the entire function. Okay, you've only graphed the function between those two endpoints. Okay? I'm also seeing people who are drawing this and then all of a sudden making this go straight and saying that's your graph. This graph does not all of a sudden go straight vertical. Okay? So don't draw it that way. That's why we're supposed to draw as many points or plot as many points as possible so that we know where this is going. Okay? Really what you should be doing if you don't have any more points is drawing that curve and then just kind of use your artistic ability and just kind of continue that curve going. Okay? It should never go perfectly vertical. All right, just kind of continue that curve. Pretend that curve keeps going. Where's it going to go? So we shouldn't have this. Something else. Even if you did continue on, and so let's say here I plot my last point so that I can see where I'm going here. I'm at 3, -9, which is here. And so if I continue on, I'm seeing people that are doing this and stopping that as their graph. Well, again, you haven't graphed the whole thing, because you have to give me the tail. You have to draw that this graph is going along that asymptote. Okay? I need to see endpoints at the end of the asymptote and at the end of the graph. I need to see arrowheads at either end of our function on the coordinate plane. Don't draw just little things in the middle of the coordinate plane. Expand it to the entire coordinate plane. Okay? Making sense what I'm asking you? All right. So, as I've said before, you cannot graph all of those points on the tail side, the asymptote side, because they get to be so small that there's just no way of graphing it. So you don't have to worry about graphing more points there, even if you have more points in your t-chart. Okay? But it is often helpful to graph more points on the increase side. Okay, the side that's going on forever, that's not along the asymptote. That side is beneficial to plot as many points until you can't plot anymore because they go off the graph. Because that really helps you see where your graph is going on that side. Okay, and it really doesn't take that much more time to do 1 or 2 extra points, depending on what the equation is. Any questions on this first example? So looking at our next example here. In the next example, we do have a little bit of shift. Okay? We have a little bit of shift. First off, looking at the equation, what's our A value? Careful, the A value is 1. The 2 is actually the B. Remember, the B is what's being raised to the exponent. So our A value is 1. That means this is going to open up, because A is positive. Correct? Okay. So now we also have a shift. And where is our shift telling us to go? To the right 4. Very good. To the right 4, because we know it's moving left or right because it's attached to the x. Okay, it's attached to the x, so we're moving left or right. And remember, x is always hexed. So it says -4. That means we're going to move to the right 4. Okay? So, now that we know this, just like we did back when we were graphing parabolas and absolute values and square root functions and all that kind of stuff, I want you to ignore the shift. We want to plot points for y equals 2 to the x power. So I usually start with -2, -1, 0, 1, and 2. And plugging in there, what is 2 to the -2 power? Right, I'm going to write that down real quick here. 2 to the -2 power. Remember, that wants to go down. It becomes 1 over 2 squared. Right? So we get 1/4. What's 2 to the -1st power? 1/2. 2 to the 0 power. It's 1. Anything to the 0 power is 1. 2 to the 1st power. And 2 squared. 4. We can probably keep going. What's 2 to the 3rd power? 8. Can we do 2 to the 4th power? Is that going to be on our graph? 2 to the 4th is going to be 16. That doesn't help us, right? We can't graph that one. So we'll stop at 3, 8. Okay, so plotting those points, but remember, all of this is without shift. By the way, if you didn't know, W/O means without. It's shorthand for without. So all of that stuff is without shift. Well, we obviously need the shift. So we need to shift everything to the right 4. So I'm going to graph these points with little x's. Back 2, up 1/4, back 1, up 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. And then each one of those points, I'm shifting right 4. Now I can draw my graph. Now please remember, you have to draw the entire graph from edge of the coordinate plane to the other edge of the coordinate plane. So this one has a really long tail on it that I've got to draw. So I start clear at the end and draw it right along that x-axis, and then I follow my curve up. All right, our next example in our notes. Okay, please remember your basic equation, your standard equation for these exponential functions is going to be y equals a times b to the x minus h power plus k. So what's our a value? 2. So is this going to open up or down? This is going to open up. Do we have shift? Yes, we do. Remember, the h value moves us left and right. So which way are we shifting left and right? We're moving then to the right 2 because x is hexed. This value here tells us we're moving to the right 2. X is hexed. Now going for the y value, this is our y value, which tells us we're shifting which way? Down 2. One thing that you're going to have to really pay close attention to is how you write your problems. Some of you get very sloppy in writing your math problems. Okay? You've got to be very careful because if this problem didn't have the k, you would have to be able to write it as y equals 2 times 3 to the x power. I'm sorry, if it didn't have the h, and then minus 2. You have to be able to notice that that 2 is not attached to the x. Okay? You got to be very careful in how you write these so that exponents actually look like exponents. Because that 2 here is not attached to the x, whereas this 2 up here is. Okay, so you got to watch very carefully. Make sure you're not accidentally putting down the wrong thing. Okay, so we know what our shift is, so now we ignore the shift. That means we want to plot y equals 2 times 3 to the x power. We ignore the shift. All right, -2, -1, 0, 1, and 2, possibly more. We have to go through and take it in steps. Y equals 2 times 3 to the -2 power. Evaluate 3 to the -2 power. What do we get? 1/9 times 2. 2/9. Okay, y equals 2 times 3 to the -1st power. What is 3 to the -1st power? 1/3 times 2. 2/3. Okay. Y equals 2 times 3 to the 0 power. What is 3 to the 0? 1 times 2. 2. Okay, next is 3 to the 1st power. 2 times 3 to the 1st. 3 to the 1st is 3 times 2 gives us 6. Then we have y equals 2 times 3 squared. 3 squared is 9 times 2, 18. So actually we don't need to graph any extra points because we're already going off of our graph. Okay. So remember, all of those points were without the shift, right? Our t-chart shows no shift. So when we graph these, we want to graph them differently than our final answer. I like to use little x's. So if I go back 2, I'm supposed to go up 2/9. 2/9 is really close to 1/8. I'm sorry, not close to 1/8, close to 1/4. Excuse me. 2/9 is close to, say, 2/8, which is 1/4. So I'm going to attempt to graph that one, even though it's going to be fairly off. It almost looks like it's on the x-axis where that's located. So if you chose not to graph that point, I would understand. Okay? But then 2/3, we can definitely graph that one going up 2/3 of the way. 0,2, obviously we can graph that. 1/6, again, obviously we can graph that. Okay? And so now we need to do the shift. So each one of these points is going to get shifted right 2, down 2. So it will look something like that. Now the last piece, before you actually draw your graph, because our graph shifted down, that is going to move the asymptote. Okay, that's going to move the asymptote. All the problems we've dealt with so far, the asymptote was the x-axis. Well, now that it shifted down, that asymptote also shifts down. And so I do need you guys to draw in the asymptote. We just draw it in as a dashed line. So that is now the asymptote. Okay, and so now that we have that all done, we can go ahead and draw in our function. So again, we need to draw the entire tail. Don't get lazy on your graphs. Draw the whole tail in. Oops, let's back that up a little bit. Something like that. Make sure you put arrowheads on both ends of your graphs. All right. Any questions on this example? So our last example today is right here. So our A value is what? 2. So does this open up or down? This is going to open up. Do we have shift? Okay, where are we shifting? Left 1. Very good, because it says plus 1 with the x. We do opposite what it says. So you go left 1, down 3. Left 1, down 3. Now we want to ignore that shift. And so we're going to plot points for y equals 2 times 4 to the x power. Okay, so we have y equals 2 times 4 to the negative 2 power. What is 4 to the negative 2 power? Remember, it wants to drop to the denominator, right? So it's 1 over 4 squared. So it's 1/16. What is 1/16 times 2? 2/16, which reduces down to 1/8. 1/8. All right, next we have y equals 2 times 4 to the negative 1st power. 4 to the negative 1st is, hello, 1/4 times 2, 1/2. Next, y equals 2 times 4 to the 0. What is 4 to the 0? 1 times 2. Then we have y equals 2 times 4 to the first. What is 4 to the first? 4 times 2. And lastly, y equals 2 times 4 squared. What is 4 squared? 16 times 2.
32.
Okay, so we are actually only able to graph 3 of these points easily. 1/8 is far too close to the x-axis. It's not easy to graph, so I'm not going to bother doing it. 32 goes off of our graph, so I'm not going to be able to graph that one either. But I can graph -1, 1/2, 0, 2, and 1/8. Those 3 points that I know their location need then to be shifted left 1, down 3. Okay, and remember, because we shifted down, we would have also done this had we shifted up. Anytime you have a vertical shift, the asymptote also moves. Our asymptote was originally the x-axis, but it's moved down, so now it's down here at y equals -3. So there's your asymptote. We can draw in our function.